welcome to this lesson. If you have been following us, we have done ionic bonding, we have done covalent bonding. So now we are concluding with metallic bonding. Under the ECZ curriculum, this is a topic that is very cardinal. The whole bonding topic, we need to understand it before we write our exams. So this is your tutor, Mr. Lord Mayor Zimba. What is this metallic bonding, or what is involved in this metallic bonding? So basically, this is a type of bonding involves the force of attraction between cations. Cations are simply positive ions, and these are metals. Cations are simply positive ions, and these are metals. What else is involved? It also involves electron in a metallic lattice structure. The attractive force between the cation, which are metals, and the sea of electrons are exceptionally strong. Cation in a sea of delocalized electron, the structure basically. So this is what a metallic lattice simply means. So this is a metallic bonding where we have the cations. Cations are the positive charged. And then we have these free moving electrons, which are called the delocalized electrons. So this simply means that each and every time you are told to draw the metallic bonding, let's say for example, they say the metallic bonding of what? Of sodium. How can you draw the metallic? So you simply, because sodium has a valence number of 1 and it's a metal, you simply need to write like this. So the free moving electrons should also be there. So this is, we have the free moving electrons, and then we have the sodium ions. So this is how we are supposed to write the metallic structure. So we follow the valence of that metal they have given us. Okay, so if it has a valence number of 2, meaning we need to write a 2 here, we need to include a 2. If it has a valence number of 3, you need to include a 3 here. That's what this means. So this is just a basic structure of a metallic bonding. So in case, let me repeat myself, in case you are writing for zinc, of which we know that zinc has a valence number of 2. So this simply means that you will be writing to plus 2 plus 2 plus 2 here. If it is copper, you do the same. Draw the metallic structure of iron 2. So they have said iron 2, which means that the valence number is 2. So this is how we're supposed to draw the metallic structure of iron 2. So this is how you draw the metallic structure of the iron, and you just need to simply label this. So this is the what? This is the iron. This is the ion, and this ion has a charge. So this is the ion, and let me just wrap this, let me erase this. Okay, so this, what I was supposed to write here. So this is This is the ion. And then we also have the free moving electrons. These are called the delocalized electrons. So these are simply the free moving electrons or the delocalized electrons. So this is how you draw the metallic bonding. And remember, these are metals. Characteristics of metal. So metallic compounds, they have a high melting point because very much heat is required to break the lattice structure. This is a strong bond. They have a very strong bond. They also conduct electricity because of the electrons which are free to move around the lattice structure. So electrons carry an electric charge. This one, under static electricity in physics, it is there. We can understand it fully. Metallic compounds, they also conduct heat because the electrons both absorb and also transfer heat to the cations very well. Metals are ductile. What does this mean? This means that they can be broken down into a wire. And the metals, they are also malleable. This means that they can be hammered into a new shape. This is because the positive ions are able to slide over each other without breaking the bond. So this is just the metallic bonding and what is involved in metallic bonding. This marks the end of this presentation. Thank you. Make sure that you subscribe, you share, and you also like this video.